Hello everyone. This video would focus on the elements of direct variation. Before we go further, please feel free to check out the description below for the link of the other series of topics related to direct variation. Before we go over this example right here, let's have a review on the definition and real-life examples of direct variation. We remember that by definition, direct variation is a type of proportionality wherein one quantity directly varies with respect to a change in another quantity. To better understand this, let's look at variable A and variable B. For a direct variation, if variable A increases, variable B will also increase. Now please notice the direction of the arrow. Both of them are increasing. On the other hand, if variable A decreases, then variable B would also decrease. Again, please notice the direction of the arrow. Both of them are going down. Again, please notice that for a direct variation, both variables have to increase or both variables have to decrease. So whenever we see this type of relationship where both variables increase or decrease, we can go ahead and say that A varies directly as B, or we can also state this as A varies proportionally as B, or A is directly proportional to B. Now let's take a look at some real-life examples of direct variation. Okay, the number of hours you work and the amount on your paycheck are directly proportional to each other, which means that if you work more hours, then it means that you get more money. On the other hand, if you work less hour, then it means that you get less on your paycheck. So again, the number of hours you work is directly proportional to the amount of your paycheck. Now let's take another example. The speed of a car and the distance traveled in a certain amount of time are directly proportional to each other, which means that if a car travels faster, then it can travel more distance. It can cover more distance at a given certain time. On the other hand, if a car travels slower speed, then it can cover less distance. This tells us that the speed of a car is directly proportional to the distance it traveled at a certain amount of time. Okay, going back to the example right here, point P is an element of a direct variation. So we have a point P right here. Again, this is an element of a direct variation. We remember that in a direct variation graph, it crosses through the point of origin at 0, 0, and it's a straight line. So we can go ahead and say that since this is a direct variation, we can come up with another point at the point of origin, because that's always the rule. If it's a direct variation, it has to cross through the point of origin 0, 0. So we already have 2 points. Again, we are supposed to determine 6 other points other than P that are also elements of the direct variation. So we can go ahead and say that the condition in order that we can tell that it's a direct variation is that it crosses through the point of origin 0, 0, and it's going to form a straight line. Now, please notice that our K value here is again equal to M, which means slope. We can go ahead and say that from the point of origin, we go up 1. So we counted 1 and 2. So we went up 2. And then that's a positive 2 because we went up. And then we go to the right 1 to get to P. So that's a plus 1 right there. So we go ahead and say that our slope is we went up 2 over 1. So this is our slope, or pretty much that is equal to 2. So that's the slope right there. So we can go ahead and say that the equation for the direct variation with point P as one of the elements would be, again, our general equation for direct variation is y equals kx. Since our k is 2, so we can go ahead and say that the equation is y equals 2x. So this is the equation of this direct variation. So we can go ahead and use the same slope, which is up 2 right 1. So I'm going to go ahead and label that down here. So we go up 2 and then right 1 every time. So I go from point P, I go up 2, 1, 2, right 1. So this is another dot. I go up 2, right 1. So I go up right there. Now we can go the opposite way as well. So that's going to be down 2, left 1. So down 2, left 1. Down 2, left 1. Down 2, left 1. So these are the elements 1, 2, 3, 4, 5, 6. That's the other 6 elements or 6 points of this direct variation. So we can go ahead and write these points on the side right here. We can go ahead and connect these dots together. As you can see, this is a graph of a direct variation because the two conditions are met. First, the line has to cross through the point of origin 0, 0, and it should be a straight line. So this is an example of a direct variation graph. And these are the 6 points that are the other elements of this direct variation. Now let's move on to the next example. Okay, in this example, point M is an element of a direct variation. Since again, we have a direct variation, we can go ahead and say that the other point is at the point of origin 0, 0. Determine 4 other points other than point M that are also the elements of a direct variation. From here, we can go ahead and determine our slope K, which is again equal to M, which is actually represented as slope. To determine the slope, from the point of origin, we go down 1. So that means that is a negative 1. And we go to the left 1, 2, 3. We went to the left 3, so that's a negative 3. So our slope then is negative 1 over negative 3. We can actually rewrite this as positive 1 over 3 because negative and the negative will come out positive. So then we can go ahead and say that the equation that we have for this graph or for this problem that we have here is again y equals kx. That's the general equation of a direct variation. Y equals our k is positive 1/3. So I can go ahead and say 1 over 3x. This is the equation for this problem that we have here. Since our slope is negative 1 over negative 3 or positive 1 over 3, we can go ahead and continue the pattern. So that's going to be go down 1, left 3. So again, this means here we go down 1 and then we go left 3. So we can go ahead and do the same thing down here. So we go down 1, left 3, 1, 2, 3. And then we can do the opposite way. I can go up 1, right 3. So from here, I can go up 1, right 3. 1, 2, 3. So this is the next dot. I go up 1, 1, 2, 3. So this is the other dot. So we can go ahead and write down the other 4 points that are considered the element of this direct variation. So these are the other 4 elements of this direct variation. So we can go ahead and sketch the graph. Again, if you notice, this is an example of a direct variation because the two conditions have been met. It passes through the point of origin 0, 0, and it is a straight line. Now let's move on to the next example. In this example, point A is an element of a direct variation. Again, we remember if we say direct variation, we are supposed to include the 0, 0 at the point of origin as one of the elements. And then from here, we can go ahead and determine the slope. So from here, from the point of origin, we go down 1. So this is a negative 1. And we go to the right 1, 2. So we went to the right 2. That's a positive 2. So we can go ahead and say that our k is equal to m, and that is again equal to the slope. And our slope here is we go down, that's again negative 1, and we go to the right 2, that's a positive 2. And so we can go ahead and say that it's negative 1/2. So our equation for direct variation is y equals kx. So the equation for this problem would be y equals negative 1/2 x. So this is the equation for this problem. Now, again, we remember that this is a negative. That means we go down. And then positive 2, we go to the right. And so we go ahead and do the same pattern here. So that's going to be down 1, right 2, 1, 2. So we go down 1, right 2. So this is the next dot. Now we can go the opposite way as well. So if we says down right, we can go ahead and say up 1, left 2. So up 1, left 2. Up 1, left 2. Up 1, left 2. So these are the other 6 points that are the elements of this direct variation. So I'm going to go ahead and write it down here. Again, this line is an example of a direct variation, or this graph is an example of a direct variation because the two conditions are met. First, it has to cross at the point of origin 0, 0, and it should be a straight line. So these are the other 6 points that are the elements of this direct variation. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!